The process for graphing a piecewise function on your TI-84 calculator can be a little tedious, but it certainly is supportive in helping us to view piecewise functions and the interactions between the different function rules. Here I have a three-part piecewise function, 3x and negative x plus 6. If I simply press graph, obviously that's not what I want. I do not want all three entire functions graphed on the same set of axes. The calculator doesn't know where I want to start and stop each graph, so I have the obligation to tell the calculator where I want to stop and start each graph. When you want to graph something as a piecewise function, it proves a little troublesome in terms of the notation. Unfortunately, in order to separate a function name, in this case, or a function rule, in this case 3, from its assigned domain, we simply use the division button to separate them. Now, you're probably thinking to yourself, how is the calculator going to know that I don't want it to use division, that I actually want it to create a piecewise function? That comes in the next part that you type. You open up a parentheses, which still actually has not solved the problem. You put the x for the value that you want to start and stop your domain. And then we use the test menu. And you might remember the test menu from an earlier video about the compound inequalities. But if we press second and test, we can choose the symbol that we want. Now, for my particular inequality, we're going to use one that's in one of our videos about functions and piecewise functions. We're going to use less than or equal to negative 4. So 6 is less than or equal to, and then we're going to stay less than or equal to negative 4. And that is how we design and set up the piecewise. We'll do the same thing for the next one. We'll use our division symbol. We'll open a parentheses. Now this one is going to be a region, so we need to be careful about how we type this. We're going to say that x is, second test, we're going to say greater than, which is option number 3, negative 4, which is where I ended the last one. Then we're going to go back into test, over to logic, and we're going to choose and. And we're going to say we want to be greater than negative 4 and less than 2. So x is back into the test menu, less than is option 5, and less than 2. And we seal it off with another parentheses. And for the last one, we'll do the exact same thing. This one is not a bounded region. This isn't between negative 4 and 2. This is just one that goes on and continues forever. So we'll do the same thing, division symbol, parentheses, and an x. And in the test menu, we will choose greater than or equal to 2. Greater than or equal to is option number 4. And we want to be greater than or equal to 2. So we have our three different parts of the function, the 3, the x, and the negative x plus 6. And then we have the three different domain restrictions. X is less than or equal to negative 4. X is greater than or equal to 2. And then the bounded region one that's in the middle. And instead of getting all three of the graphs together when I graph them, now I get the three individual parts.